And hello, we are back. And if you were just on stream before with us doing some Haskell, there's a bit of a cliffhanger there with regard to our compilation of accelerate examples for the NBody problems on the GPU. But this is not what we're doing right now. We're back on our Chronofold implementation in Purescript. And turns out that last time we did some really good progress. And we actually, in my view, implemented the CT merge algorithm. So we can kind of focus now on more the performance side of things and a prototype. And so performance-wise, I was starting to get set up in installing the benchmark or bench shortrons, actually, suite of tools. And so we're going to do a few basic things just to kind of kick the tires of performance and see where this takes us. Let's think a little bit about what we actually want to test in the benchmarks. If we look at our main test, at the beginning, we do some, well, we creating some empty log. So having an empty log and then appending the same character like 1,000 times seems like that's probably a proper thing to do. And so they would probably look a little bit like this, but just for one replica. So let's see if we can get that working. So I think we'll call this maybe append bench, and we will do something like maybe put this inside a let clause, and we will remove the beta related things, and ops we're going to do an X. Oh, right, but no, we want the code that's able to take ops as opposed to just one op. So let's copy this instead. And so alpha ops, alpha ops will be on top of alpha log root. That's okay. I'm happy with that. Oh, we're changing a little bit how this is done, and that's fine. And so we will right, sizes. Gen. Right. So our append function will take some n, that's the vector of arbitrary size, and these will be passed to specific sizes. So n, so it means that append bench is actually int to, well, log, I suppose. It depends what we return. And we will call it here append, maybe. That will be more elegant. And yeah, I mean, this is a vector vent, I suppose, and it looks like it is. And then we'll just comment that and keep it around. Just, oh, a la additive. That's pretty cool. Feels like deriving via. That's pretty awesome. I didn't notice that. Okay, so what are we doing? We're creating an array. Well, we're creating a string. So how are we going to do that? Our string foo is still not very good, but it seems like code unit actually has quite a lot of the stuff we want. Is there something like replicate in here, or duplicate, or repeat? There isn't. Okay. So our string foo is already failing. There's not a lot of a constructory thing. There's a from char array there, but we don't know at all how much, we're going to be measuring actually the performance of that thing. I suppose we could also bench it. Let's see. Let's try and take a look at the source code there. I mean, this is going to be quite a lot in the details, right? How much memory and but to be honest, string construction, I suppose, maybe that's the last of our issue at this point, because we're folding over it anyway. So it would make more sense, in fact, to have like a lower level version of build snock that would append. And in fact, don't we have that? Let's see. We have build. Our build snock strings up actually called build snock up, and build snock up just takes a code point. So we could build an array of code points, and that would just work. So let's do that. Then we can just use the array. That's not arrays. Here, use the arrays to replicate, and this should have a replicate, right? Yeah. Sorry. Okay, so very good, very good. So we are using building snock up instead of snock ops. Oh, snock ops, right? Not snock up. Oh no, snock up. Oh. Okay, so we just need to fold over that and call it a day. Are we getting ops from that? I suppose I should differentiate the building of the snock up from the appending of the snock up, because I think I'm doing redundant work. Okay, so then maybe there should be a utility function here, but for now we will do build ops, which would take an int and return an array of ops of op. And then when we do build, we won't do build snock up here. We do append ops, right? Append ops and well, we can't do a pre function that's not going to be benched, or maybe we can, but I need to check this out. Yeah, because build ops is already going to be a fold, right, of build snock ops. Of say alpha log root. And Oh yeah, now we're going to want to fold L, I think. Array fold L. Let's get this guy in. Yeah, we'll start with snookops. Append something and build ups. Build ups, and append can be commented out for now. And we need to import our Chronofold. And more things from that array. As array. And build snock up. And fold L takes something that takes a B, our log, the A, our code point, the B, our returns a log, so that builds snock up, we're good. Alpha log root is the empty log we're looking for. No, it's not. It's not. We are getting an op. We're appending it. Are we getting where we're getting the we're getting the ops and the op, and we are building the op and appending it to the ops. And it's not an op, it's a CP. And we apply it there. And we start with an empty array. And we pass it the replicate. So we'll say whatever string or whatever. Okay. Code points equals a replicate n of, let's say, x, and that's an array of code points. If we make this a code point, which can be done by using code point from chart. And hey, let's use B, why not? And one less character if we do this like this. Okay. And this is array replicate, but you know what? Let's not. Are you using the foldable instances here? Fine, array replicate. And this is from data string. And you don't like the range operator? Yeah, that came from data array, didn't it? Import data.array. And you want an op here. B is ops. Oh. Why do you want an op? An FA. Right, when do we actually use the code points? That's a good point. We need to be passing our array. Whoopsie. Here, right? But apparently I'm not doing this properly. So let's say this is go, and say go ops cp equals this, and I see. Let's type go because I'm so it should be taking an array of ops, okay, and a cut point, and return an array of op. I think that's the principle, isn't it? So it's just that this is an op and I'm not using the right thing. This should be cons, but okay, array. Or is it snock? I think it's cons this time, isn't it? No, it's snock. Okay, so snock takes the array, which is ops, and the op, and we mean array snock. Okay, progress. Could not match int with array blah. Okay, let's take a look at these examples that I lifted this from. Actually, again, doing this thing again. Ventrotron. Example. What's the type of folder? Bench take a string and a function of a to r for all a. Oh, I see. Right, the vector and arbitrary. I see. That's fine, but I think this is what we're doing. We're passing this n, and then we are in fact in build ops wanting to pass the cut points, in fact. So go from an array of cut points, cut point to and I guess we could make this point free, but there's really no point. Haha. And could not make array with gen. Right. So in fact, I'm not using the right. So I should use some kind of array of n if I can. And but I don't want it to be arbitrary. Is the problem. I want it to be cut points. So I'm going to start to create arbitrary instances, which we're going to need in any case. So it's not a bad thing. Is that the tutorial for, it's for Haskell, okay. Repeatable, array of, well, so that would definitely want something like that. But we'll want a cut point gen, and maybe there is one. Purescript cut point gen. Arbitrary strings. Interesting. So that's seems to be the genesis of, instead of using array char, using array of quote point for strings. So I want to understand that. Okay, so I think, okay, that's just one additional layer of abstraction because we could be using it UTF-32. So that's not really the reason why strings aren't array of chars. We have data strict gen, and that doesn't generate code points, unfortunately. Can we type annotate such that if we do array of, then we can actually do array of and we say something like arbitrary of type code point. Of type gen code point. That's here, no? Maybe we only need the class. Is it a class? Well, yeah, we might want it to be a type. I don't know what I'm talking about. Gen. It is a new type. So, oh, but it comes from gen, not from vector of. And you don't have an arbitrary instance for quote point. That looks fine. Except that we're going to have an orphan instance problem. Ugh. Pretty sure that if we say that we build an arbitrary instance, okay, let's look at the main doc here. There's no real walkthrough. I guess that's one of the, oh no, there is a guide. Wonderful. Based tasting. Right, so that's the kind of thing we want to do. And I remember we were actually trying to do this right here. An arbitrary replica. Well, let's first focus on an arbitrary quote point. It's going to be a simpler thing. And arbitrary equals, it maps arbitrary, which I suppose is a number. By default. And then we do maybe, how about we do 2 in num? Might not be a bad idea. Oh, well, without the, and arb code point. And no type class arbitrary. Class arbitrary. And we import this. And we have an orphan instance. Or define the instance in new type wrapper. Okay, new type wrapper it shall be. New type CP equals code point. Now how it works. CP Do I need a wrapper? I think I need a wrapper. CP and code point, and then I do my CP, I suppose. Yeah. But then we want an instance for CP. And then what can we just unwrap here? From a new type. Not like that. Quick check black, blah blah. Oh. A general function. Okay, maybe map unwrap. And we can derive instance new type of, I think that's how it works. But we need to do this underneath the gen, and you're not happy with that because there's no new type instance for gen. Yeah. So, okay, we do RSCP and we RSPECT, yeah. Let's look at the required type of benchotron of that gen function. Int to gen A. Into gen A. Yeah, so we map unwrap here. But if we do it in this order, and that arbitrary gives us some into something, then 2 in them is not going to be good enough, it looks like. Okay, well, I suppose we could maybe it and create some arbitrary code point. As the default value with the identity. and otherwise run to enum on it. I don't know if that's going to be 0.3 enough for this thing. That should be data maybe. And we don't quite have it. Yeah, I think that's because I am not good at writing 0.3 code, but oh yeah, we can do this maybe with the anonymous notation. No, we can't. Fine, lambda it is. And looks like it's actually doing something. Let's run it. The builds. And, well, that seemed fast. We're only building operations, which is only an array. It's only an array, but we're doing some stuff with the append up and build snuck up. That's all doing, I mean, build snuck up is actually calling append up, and so this is all doing stuff. Okay, so we're supposed to be opening that, aren't we? Don't know where you did this, but yeah, Purescript Chronofold, and we're supposed to upload this here, I believe. And that's quite a strange thing. It did a similar, there was a similar weirdness, I think with the sum, wasn't there? There was this weirdness. It's a little bit strange. And I don't know if I can convince myself that this is doing what it says it's doing. Let's do it for, let's say, 10. I have no idea what this notation is, by the way. It's pretty, but is that apply? fmap, some kind of, I don't know. And let's do time 10. Such that if we print somewhere, and I can save print, like basically spy, right? So let's trace things. Import debug trace, and let's spy our array up. Yeah, 10 should be reasonable. So our like we could just spy the whole thing there. Array and go. You're unhappy with the, oh, well, yeah, of course, that's not gonna do it. And okay, well, maybe you can use the range notation like this. Yes, you can. And yeah, we get lots of spied things. So it's definitely not doing nothing. And we have some crazy value in there as well. You seem to have quite a bit of 66 for some reason. That's not extraordinarily diverse. Is that like, why is this so monochromatic? I suspect this is this may be actually, or this 2 enum kind of failing. We don't even know what it's supposed to be, right? So can we say, hey, generate int? Looks like we can. Is that going to change anything? Nope. I suppose B is 66. Okay, I think in the char module there is a from ASCII code or whatever. From car code gives us a maybe char, probably better than Trinum. And then we need to take the code, take the code point to the char, like so, right? Oh, maybe char. Therefore, here. And therefore just be here. Yeah. And you're unhappy because of partiality. That's fine. What? No more spying? What? Why? So this time you're not even bothering. How is that even possible? Okay, I suppose this is 10. -C. Okay. Something strange happened there. But those numbers look somewhat better. These are arrays of size 2. They seem to be only arrays of size 2. No, that's an array of size 1. Oh boy. Okay. Let's not run this suite. Instead, let's try and exercise our arbitrary instance in the way explained with this tutorial. So let's import test.quickcheck. And then consider, therefore, that we have quick check available to us. And we can pass it okay, what am I doing? Then we can pass it some function that would take a CP of P to, okay, yeah, something will spy on, and in fact will return something and spy on the other thing. Spy on P and will return true. Okay. Well, that looks reasonable. Can we convert this to chars just to see whether that kind of makes sense also from the char perspective. So map singleton to these things. No, it's 2 in MP I need to do, isn't it? Or no, singleton takes a cock pointer string, so just singleton. Okay. Yeah, that's probably fine. Looks very diverse. Not even a single Latin character, but I think from the point of view of the Unicode character space, that's likely to occur. So then then what? Then what is this generation function is one question. Is it properly generating something? And how do we know that? Array of returns a gen. So from a type perspective, what do we do with the gen? We can ungen it, which supposes the state implementation. Interesting. Okay, that's using a generator, that's not eliminating a generator. Evalgen runs a random generator, keeping only the randomly generated result. Let's try this. Evalgen of, let's say, a simple arbitrary gen CP, like so one single character, I presume. We need to pass it a gen state. Where are we going to get such a thing? It's just a seed and a size. So we can probably just pass it directly. And the size is an int. And the seed is something we can run mkseed on an int with. And that shall be a colon. And evalgen comes from QuickChatGen. So that's... And yeah, right, effect unit. So we're returning what? A with this? Evalgen returns an A, yeah. So let's log show it. You can show CP. That's a bit of laziness there, I would say. Can we just derive new type instance show CP string CP? Nope. You don't know string? Yeah, that's right. It's show. And you seem to be able to. And we show our code point. And let's try again. Well, I guess our seed will make it so that it's the same. Yeah. Modifying the current seed, being passed a number. Oh wow, that's in the fmonad. That's old school. So I think this makes sense, except for the fact that, yeah, what if we want an array of CP, which I think is what we're asking for here, array of. Yeah, we get one. We can just get one. And so why do we have to... We're passing an n that we're just not using here, in fact. Because array of doesn't need that. I suppose we could use array of size or something. That's probably exists. Array of 1, list of. No, we can't really say anything. Oh, vec is actually an array. I see. Well, then we find our... we found what's going on. And we can probably just comment all this again and run the suite. And this might be a little bit overwhelming. We're still running it only with 10. But now it looks like proper. Yeah, like those are nice arrays. Okay. Okay, much better. And so let's not spy on you anymore. And let's just go. Oh, well, that's just going to be for 10. So we need also to do something here for more stuff. And that's pretty slow already for 10. So I think we might, yeah. Okay, you know what? We'll do 10, 100, 500, and 1,000. Not so terrible. And what I'd like to do also is to profile this with the V8 profiler. And but before we do that, let's check the rendering. Okay. And mean running time, I suppose, per op. So ideally we want this to be linear. I think that's what it's supposed to be. Right, I mean, let's look at the free things again. Benchmark, left bind large. Yeah, I think that's it. We want it to be linear and fast. So let's just do the, well, actually, let's try and profile this with V8 already, which I suppose is going to be this with the profiler. So node profiler. Oh, can we access this remotely with Edge, or are we gonna have to? Yeah, it seems like we can. Good. Minus inspect. That's the trick here. I think I need to break on the first thing. Right, isn't there a way to break? How do we node inspect break? Node inspect. It's just node inspect, not dash inspect. Okay. And the debugger is listening, and so we should be able to do edge inspect and launch the thing for node. And there we go. Reattached. And we shall be ready to go pretty soon if we say allocation instrumentation and allocate things and start and then run, which would be this. And so are you running? Well, it's recording, but it's outputting nothing to the console, so that's a little bit strange. I'm missing something, aren't I? Oh no, you're good. You're going. You're just very slow for some reason, but you're going. Great. Slow to start, at least. Not sure why. Oh, you can reset. What? Why? Why is that? Snapshotting. I wonder if it's actually tracing the right thing, because there seems to be a remote target here as well. I have no idea though why the connection resets, nor why things are snapshotting forever here, or nor why it started so slowly. Maybe just some warm-up of the profiling instrumentation thingy. But visibly not doing anything. So, okay, let's try again. It's using a strange... Okay, you're attached. I'm happy with that. Let's start you. And let's start you. And let's say can't. You're not happy about that. Can only perform preparation was paused. Okay, so yeah, you're not paused anymore. I guess probably does the same thing. But let's check. Let's stop it in. Let's pause him. Where are we, by the way? In the file system. Okay. Yeah, I guess we are not Yeah, we're not profiling. We're profiling the whole benchmark tool. That's not the smartest. And maybe that's why things are a bit unwieldy. So if I say const, you're happy? Yeah, so it does work. And then we are recording, and let's take a look at system resources, task manager. Okay, we're running stuff. Memory usage is in appearance flat, but we are at a pretty big, and still icon reset. Internal error and not inspect. Okay. I suppose we'll need to trace this. That's not pleasant. Callback trampoline. Okay, callback trampoline sounds like some Stack Overflow in reality. So, so let's try just with 100. And go back to our DevTools, and we're ready to go. No, we're not ready to go because we're still recording, and I need to stop recording and delete everything and garbage collect, why not, and then run you. Maybe it's not happy about the fact that I'm running this from inside inside this terminal there. Maybe I should try and run this from something like Alacrity or something. Looks like it's ran, and it's not completely unhappy, so we can stop, and it's finished. And we have what looks like a, oh no, it's not an empty timeline. Well, I mean the timeline is empty, in fact. So why is that? I asked to record stuff, but you didn't do much timeline-wise. There's maybe because I'm charting the memory instead of the profiler. I think in Chrome this works better, but I'm not sure. Profiler doesn't even appear. Kilo, mega, that's 4 megas, 4 megs. Yeah, that's bad, no? Compiled code, Lodash. Yeah, that's the whole benchmark machinery, so I think maybe let's do a simpler thing. Where we don't run the suites, we just build ops, or yeah, build ops, right? Yeah, build ops of like some array of code points. Like, well, I guess we could use the arbitrary, the eval gen actually. We could do that. That's probably fine. So maybe we we let our example be something of size 1000, which I think is reasonable. And then we use build up with eval_gen. And build ups takes an array code point, and eval_gen is not what we wanted, it's example. And we have an unexpected token, that's because we should probably do in. And we need to unwrap our things. Which I suppose we could do by mapping unwrap here, right? And that's an array, so I guess we can do, I guess we need to be in a do block, and just mean to discard this. I'll just do pure init afterwards. Array with effect. Do we have to discard this explicitly? That's strange. Oh, example is example has example type effect. Oh, right, it might, because I haven't parenthesized this correctly. Is that the problem? No. I expect this to be an array of code point, but visibly that's not the case. No, that seems like that's actually the right type. So what am I missing here? I return an array of op. I can do whatever I want with it, right? I can discard it. Do I have to wrap it? I do have to wrap it. Okay. So I suppose I could do this, right? Nope. Oh, right. Okay. Fine. Do pure unit and do pure ops example. You're not even going to do that. Is it because my prelude is messed up? I don't know. I think am I still misunderstanding some of this fundamental stuff? This is strange. Okay, so can I just run main? And delete things. So maybe let's try with another approach to profiling. And go. And it's done, I think. And it still uses a meg and is doing a lot of slicing. Oh, just to read file. Why are you reading a file? Is that just Node reading the code? Okay, I think I can't read this profiling thing. I'll try again. We're connected, right? are. And we start. It's not even clear whether it's finished yet or not. Well, it definitely doesn't do any timeline things, which I thought it would, but it doesn't. Oh, and this is definitely laid out better in Chrome. 325. And I have nothing selected right now for some reason, whereas before I did. Node environment. This is all node things. Maybe I need something simpler. Maybe I just need to hear node basic runtime profile. I just want to know like the basic memory usage and so on. But I don't think such a thing exists. Okay, well that's dead. Never heard of that thing. Expose GC. I suppose that's exactly what the node interface does. Okay, is that a usable thing? That's manual instrumentation. You can actually subscribe to a leak event, which detects 5 consecutive garbage collections. Oh no, we detect heap growth for 5 consecutive GCs. Look at heap usage right after V8 performs garbage collection. And what is exactly this? Checks heap usage after GC to give you a stable baseline of actual memory usage. When V8 performs a garbage collection, technically we're talking about a 4GC with heap compaction, then watch what we mean the stats event. Stat data will look something like this. And this looks pretty cool for some pretty granular detection of things. Before, after. Huh. It actually shows string arrays and classes. Okay, let's see if this is a shot. npm i -sfdev node memwatch. And then let's create a small bench.js file. And let's do what we're doing in our npm run bench, which is requiring the module. Well, let's require the module. And let's start by seeing whether we can detect a leak. You can't even build this. Years ago. How's next? 5 years ago. Oh boy. Yeah. And was not a member of V8. Yeah, I suppose that trying to track this for later versions of Node is just an impossible task for a single developer. Okay. Can set breakpoints. Inspect memory usage in Node. That's process.memory usage. Can we diff? Actually, we might not even need to, right? We're actually launching the process right here. Node bench.js. So what are we seeing? Resident set size, total memory allocated for the process execution. If we don't run bench main, what does this give? Yeah, it's still allocating about 34 meg, so that's just the basics. And the heap change is very small. What if we don't even import? Hey, Carotical, good to see you. I think we are, it's just you and I in chat right now. Happy New Year, by the way. I saw you were also streaming yesterday. Passion, huh? Thank you, thank you. I was doing some Haskell earlier, but I went back to Purescript. I mean, I wasn't doing some Haskell. I was trying to install Haskell, the accelerate package on Windows, and it was mostly tooling. Oh, wow, amazing. Do you mean you finished Chris's optics book, or you're talking about something you've been reading off screen? It's, mostly annoying, it's definitely not the beauty of strongly typed functional programming. It's more like the mess of yeah, systems things. Oh, excellent, excellent. So what's next on your list then? Do you have another book to go through? Do you know Sandy McGuire's book on algebraic data or algebraic design? That's definitely one I wanted. Algorithm design. Well, that sounds like a really good one too. Excellent. Oh, nice, nice. That'd be great. That would totally be great. Nice, nice to know. Yeah. Yeah. I'm trying to pay some attention to performance in Node. I've done like my first naive implementation of the Chronofold's actually working. Actually, I can walk you through it if you want. Others not going to toot my own too much here. Hey, well, that's good. Toot away. Okay, sure thing. So, Chronofold is a data structure for version text, and it's pretty recent, and it's basically the tip of a type of work focused on CRDTs, right? And I mentioned that earlier. And the kind of early work on this is operational transform, and this was used in Google Docs. And a lot of iterations has happened in both industry and academia on this, giving rise to a lot of different structures, and obviously at some point also beyond just versioning text. And what one of the things that's interesting about or the type of thing that you want to have from your CRDTs is that you'd want to have, let's say hundreds of replicas all around, and each of them could be both reading and writing to a shared data structure. And after some time, there would be eventual consistency between all replicas after they've all exchanged whatever synchronization message they need to exchange. And that this would be also somewhat tolerant with respect to what the transport guarantees are with regards to message delivery. So meaning different CRDTs would tolerate better, duplicate messages or out of order messages, things like that. So idempotency, commutativity become important to determine what the characteristics of your CRDT are going to be. And so there's a whole body of work on that in academia. And, I like real-time syncing things. And so that's why I'm interested in that. And Chronofold specifically, I think, is kind of best of breed in terms of applying that CRDT research, but also making sure that it's doing so really fast for the special case of texts. So if you, for instance, look at the blog post that VS Code has done, they are chasing performance increase by implementing data structures that fit very well the use case of text. So, no slicing and the ability to also have your data structure optimized for line by line reading. So they end up with a structure that's actually in a multiple buffer piece table with a red-black tree optimized for the line model. So, it's a specialized data structure, but using red-black trees, which are fairly common. And in fact, Atom also followed a similar path, and Atom had also tried to basically say, okay, well, we have a super efficient data structure locally. Can we also do real-time sync on the back of that same data structure? And that's basically exactly what Chronofold is doing. It's paying attention to the state-of-the-art in terms of text implementation and CRDTs, and comes up with this particular data structure called a Chronofold, which aims to address this use case. And I've been playing with implementing it in Purescript. There is a Rust implementation, and I think the author might have a C++ implementation, but that's not public. And yeah, I'm playing with that, and it's pretty cool. There's now I think I have at least a converging what is it, test node. I have a set of tests that that properly converge with a variety of examples that are taken from the paper, some YouTube presentation that the author did on the paper, and then some older blog post that was pretty widely shared around how to use this type of approach with these causal trees for something else than text, like in this case, collaborative diagram drawing. Let me show you. So just a quick test things. I run some tests, and so this, I haven't worked on the API yet, and I also haven't worked on some of the implementation or the optimization that are suggested in the paper. But you know, you tag replicas, and then there's a way to initialize the data structure with sort of a root atom of sorts at the beginning, and then operations are created on each replica. And here I'm reproducing this example. And so here, this actually is one of the best ways to introduce what the data structure looks like. So, and it turns out that that's also what I implemented here with this example right here. No, beta log Pinsk, right? That's the big one, I believe. Yeah. So here we start with alpha 6 being the, let's say, author, and which and writing pins all caps. And so in the data structure, we're maintaining a local index and then a, let's say, shared index. And in the shared index, we have we basically, they're called timestamps, and they have a replica and an incrementable number. And we basically get a total order on all replicas and all text entries by ordering in an arbitrary manner the replicas and their indexing. So that if basically two replicas try to insert at the same time, then we arbitrarily say, and so in all replicas, that we choose one over the other. And through that, we have a total order over all the operations, and we can recover, we can converge towards the same result on all replicas. And here, beta is exactly alpha, beta, and gamma here are authors. The paper uses different terms: process, author. I think of them as replicas. They could be on different machines, they could be in the same machine, but you know, the main CRDT use case is they're on different machines. And so, yeah, in process alpha, let's say author alpha writes Pinsk. And then in process beta, beta receives the operations from alpha, and gamma also receives the operations from beta. And so now, after this 3 arrows here, everybody is at the same initial state with Pinsk in front of them and inside their array. And so beta has exactly those things in its own local chronofold, including the annotated by alpha. But conceptually, you could think of the upper number here, 1, 2, 3, as varying depending whether you're on alpha, beta, or gamma, because that's your, let's say, your subjective index. And that's something that's actually used in the paper, subjective ordering. And I'll explain why. So, so now beta and gamma are going to do concurrent edits. And so beta position its cursors just after P, presses backspace, and then enters a capital M. And so ends up in state Minsk. And then concurrently gamma actually leaves its cursor at the end of the K there and enters 4 deletes and then writes INSK in lowercase. And so now we have two, let's say, conflicts or two replicas that have entered things just right after, like simultaneously, right? And so in this scenario, now alpha receives the beta information, but that doesn't matter so much. What matters is what beta and gamma do. So beta now sees gamma and adds at the end. So this is alpha 6 beta 8 is the state of the chronofold on beta. So it's beta 8 because it added a beta 7 and a beta 8, right? Just 2 characters. And the state of the chronofold on gamma is alpha 6 gamma 14 because it actually entered quite a bit of characters to get to its own state. And then what happens is that gamma appends the beta 8 characters at the end of its chronofold, and beta appends the gamma operations at the end of its chronofold. And so what you end up with is chronofolds that are in a different order, but because of the character of each of the elements of the chronofold and the nature of the merge resolution algorithm, everybody is able to converge to the same result in the end. And so what is the data that is kept in the data structure to allow that is what's called a weave in this domain, which is basically a linked list of basically that the delete comes after the P, that the M comes after the delete, and then therefore the M is followed by the I here. And so by knowing that beta 7 depends on alpha 2, which is called the causal parent, we know that basically we know that beta 7 that we care about the fact that beta 7 has done something to the distributed data structure after it had seen alpha 2. And gamma 7 here, because it deletes alpha 6, we know that gamma 7 had seen all the data until alpha 6. And that is what is basically the essence of this merge resolution algorithm, which is that if two branches depend on the same causal parent, then we just need to order them by their total order. Beta 7 the parent or alpha 1. So beta 7 is the children of alpha 2 in this case. And yeah, that's it. And so in fact, what I realized after doing more on this, yeah, causal parent, that's right. Causal parent. And the essence, one of the essence, I think, of the paper, and that's in fact the way that a more general family of CRDTs address this case, known as causal trees, or RGA, meaning replicable growable array, and they are meant for ordered collections. It is that when two branches have the same parent, then you apply this algorithm, which basically says something like if two operations have the same parent, which is called finding a preemptive CT sibling at the same location, then you insert ops after your sibling if it preempted you, if it has higher priority than you. And at first, I actually thought that this example there had a preemptive CT sibling, but it doesn't. But this one does here. and right here. Yeah. And so I implemented both of these tests in my tests, and yeah, the idea is that everyone converges towards a control out there. Yeah, it's pretty cool, and I think there's almost like something about building these CRDTs a bit in a kit. And the author that did this also came up with this Ron a while back, actually. And this has a Haskell implementation here. And he also did JavaScript. He has done earlier work on that. And there's a concept of basically sort of composing data structures that have this replicated, conflict-free replicated data type capability. All right. It's possible. I don't remember. I've done this presentation a number of times now. But yeah, the idea, it feels like, it's a new way to think about data, right? Like a little bit in between a local data structure and a database on the server. Like if all of your peers are actually participating in a CRDT swarm and they're all exchanging messages, then you can get eventual consistency on data sets without using a central server. And also with good offline capabilities, which is part of some of the stuff that this author has been kind of focused on. Oh, okay. Maybe it's not very loud. It's one of the things. It's very. I actually chose an ambient playlist, so that must be quite low. But thanks for saying that. I bet others would feel the same if they were others. Yeah, and so this family of CRDT seems to be kind of the best of both worlds. Normally, you have to choose between convergent replicated data types and commutative data types, and this approach there where you could have a data type that can real-time sync, where you send up by up if you can afford that, and then also if you've been disconnected for a little bit or you want to batch your updates, then you can do periodic sync. And then you can also just ship the state, because maybe sending 100 operation is actually larger than just shipping a state that's actually small. And so this kind of gear switching thing that this author has been focusing on, same guy, Viktor Grushenko, who wrote this paper, that I think is a really smart way to do things. And he's been supported by Protocol Labs, the folks behind the IPFS. So yeah, so that's it. And I have a first implementation, the tests pass, and now I was looking at performance, at least to have a baseline, because I haven't implemented all of the optimizations he suggests. Some of them are about, avoiding splicing your array and taking care of your complexity. He has some interesting co-structures to also do things that are specifically interesting for text editors, like storing ranges, references to character ranges, and meaning like things like both cursors and selections and formatting, and basically have those compose well with your main text chronofold and have everything be real-time synced. And I think this approach can be extended to probably more than text. And so I wanted to implement it just so that I can get a good sense of then whether you can do real-time sync in a kit, by taking this thing here, and end it up with a replicated data type. So that's what I've been doing. And yeah, it's fun. Where are you based, by the way, Carticle? It's Barry, right? Oh, cool, Boston. I'm in Berlin. So I was trying to understand the node memory profiling tools. Oh, cool. Yeah, that's where I met Chris when he was living here a couple of years ago. Okay. So, memory usage. Oh yeah, Windows is a little bit terrible. But I've been trying to tame the beast a little bit. Even though I could do, WSL and have my code running in an Ubuntu container and be happy, I think I'm suffering a bit through trying to understand the Windows, or re-understand the Windows world after maybe 20 years of not using it at all. Okay, let's close all this and let's see. Well, you know what? Maybe not when used on the GPU, which is what I was. But you know what? Just to brag a bit, I think. Oh, actually, I thought it terminated, but it might not have. Oh no, I'm getting a permission denied. I thought I finally got it to compile, and I also I need to compile it with an LLVM backend, and this seems to be also kind of a whole other thing. Yeah, the bots are terrible. I don't know why. Plus, did you notice? Like they seem to be always doing pretty much the same thing, basically abusing the Unicode, the large Unicode space of characters to try and fool the spam detectors. But how dumb are those spam detectors? But anyway, right. So I'm not even sure what I'm measuring here, and this seems like not detailed enough for me to be able to really measure things like in megabytes. That's not it's not enough. Yeah, I do the same thing. Sounds good. Excellent. I'm gonna probably play some RimWorld again after I'm done with this and I'm after dinner. So enjoy your D&D session. That sounds like a lot of fun. And thanks again for the Discord stuff and whatnot. See you later. Okay. This is a nice diagram. All these GC things. Maybe I want to start by, I think I might want to do some manual annotation to detect, to measure time, which I think is available in Node. High precision timer, performance measurement API. And that's the guy. We can use performance measure, performance mark, high resolution time. I am not using. I have used Purescript for work before, but for more of a prototype project. But I'm starting with Wire actually on Monday, so I'll be doing more Haskell and kind of backend ops things. I was doing more Kubernetes things in the back. Yeah, I'm super happy with that. It's really super smart and nice people there. So my first time in a real Haskell shop, so really super happy with that. Okay, that's a W3C API. Tom Harris timestamp, performance interface, now time origin. So these are the people I think we're looking for. Now the perf hooks. Oh, this is really not a great entry here. Duration of async operations. Okay, I think we do performance of mark A and then performance A to now. With the proper imports. Bench is not defined because we forgot to import it. And that's all great, but it doesn't print anything. Console log. I see. We need the observer to do the printing job. I see. Except I removed it from the imports. And it's not working because I probably need to observe before I do other things, and that's correct. So my what is it, 1000? Yeah, my size 1000 example takes 9 what? What am I printing? Get entries. Entry duration millisecond elapsed for this. So only 9 milliseconds for 1000. An array of size 1000. So let's see. Yeah, you could at least I don't know, print the item. What, the item entry type maybe? Okay. Measure 6.9. Milliseconds. And name. We want the name. Oh my, I'm doing JavaScript. Measure now blah. Okay, that's good. So now I can do things like, well, I can't pass oh boy, now I'm thinking I'm thinking I'm thinking JavaScript FFI thoughts, like passing the performance. Hold on. Is there node performance API in Purescript? No, I don't think so. I guess we could maybe do that. That seemed like a big tangent. So can we okay, maybe we can do something like this. Maybe we can say this is one of the examples. And if we export build-ups, then couldn't we do benchmark dot build-ups of, bench of bench dot example? Would that work? It does, and it's what? Build-ups and main. Oh, yeah. I need to say this is build-ups. And therefore this is build-ups. And now we mark here, this would be main. And then we measure this at main. Yeah. Let's check if we get the same result. But we return unit, right? I return unit from main, and so I should be, let's be a bit more, a bit nicer, and then we return unit from main, yeah, and 366 more item, and so yet build-ups takes more time. Okay, and but could it be because of the GC the just-in-time warm-up? Yes, it absolutely could be. Let's also make sure that I'm using the API correctly here. So I'm marking marking A2 now. This is main to now, and this should be build-ups to build-ups, right? Or do I have to do main to build-ups here? And then reverse it. Yeah, no, that seems like that's different. And the fact that we're clearing marks here is also maybe we need to not do that. Okay, 6.6. Why is this not commented? What's happening with the renderer here? Oh, weirdness. So we kind of do want to warm up the code loading, getting inconsistency because of this. And then at the 9 millisecond bar. Then I want to kind of see, yeah, what it takes if we do like a simple Purescript based array, whatever. It's a thing where we take, well, we just return an array of, let's say, let's build a thing with some meat inside, like some string and some number, and maybe some like either like thing as some type, like one or other or something. Can we even do that? Let's just say maybe bool. How about that? And then can we just arbitrarily generate that? We might be able to by just saying eval_gen arbitrary. A boolean. Wow. Very cool. And so if I get my array from JavaScript, then what happens? And let's still do it in this way, even though it's a little bit weird. Var r equals bench dot array whatever. And then show me the r. Well, still the same the same seed, but looks good. Let's do it, and then let's do a refactor. Let's say const mark2 equals mark2, and then do mark2. And no, actually, let's say array whatever mark 2. And let's remove this log statement. Okay, yeah, this takes a super tiny amount of time, which is good because it's not supposed to take a while. We're really only measuring the arbitrary generation, but 1,000, it takes a bit more time, right? Well, almost not. Which is still makes sense, but it probably also means that we're not precise enough when we're measuring things. But okay, well, let's not just build it. Let's also fold over it. Fold whatever. Or fold what. And that's going to be an array of our thing, but we're going to fold L over the array. And I don't know, we'll do like something like name number either. We'll use all of those. We'll say something like either is actually a thing, right? It is, but we want to use maybe. We say, well, show the number depending on what's in either. And identity, well, let's say, how about we say const name here. Is that gonna work? Array fold L. Yes, yes, we need to have our whatever types in them. Whoopsie. Oh, right, of course. No, this is now a, well, hold on. What am I doing here? I'm doing nonsense is what I'm doing. I need some accumulator. And let's make this an empty string. And then I'm passing the accumulator together with this thing. And then I'm appending the accumulator to the maybe, and this is a string. Except I'm not doing anything with fold what. I don't think I've made things any better at all. Yeah, I haven't. So that's, I was thinking I was being smart with reuse, but I was being really dumb. It's all good. And this would be fold what, right? How long do you take fold what? Such a small amount of time. And I mean, I want to be sure again, but you are 1,000 wrong, right? Not a function. Yeah, no, you're 466 long. Yeah, we don't have control about the exact length because we don't use the array of or the vector of instance with 1,000 of arbitrary. Is that right? Oh yeah, that that is right. So cool. Here we're actually only doing 100. Huh. So we need to be doing 1,000, and then we're going to be very marginally more. And let's remove the console log here. So I guess that's our baseline. We can sort of put it in here and say it's a baseline. It's slow, and that's just what it is. I suppose I can... I haven't even done the append. I should do the append. But I should also say to bench like just a regular fold, right? Passing the array code point. It doesn't matter what it returns, right? So we should be able to say array cp to string and say, okay, let's build another one. Fold whatever. Fold cp, fold baseline, where we do this. To R. So in fact we can point free that boy and then say array of, well, we can say CP. I mean, it's actually polymorphic, isn't it? Full baseline. Bench fn of fold array, full baseline. And yeah, sure, of course. No, it's absolutely not polymorphic at all. So we take the array of CP and we do something a little bit stupid. We just append it, right? We take our CP and we convert it to some, I think we're going to need a maybe again. We convert it to some what? This is kind of fold concat string, is really what it's going to be. And we're going to do one of our code pointer string thingies, which is just what, singleton CP? I think so. A recipe with string. Yeah. Oh, I'm forgetting to pass things here, I think. CP with code point. Yep. CP. But for some reason, build up doesn't build anymore. That is quite strange. Array code point. Oh, I see. Okay. So CP then. Yeah. And what? And then we run the benchmarks. It'd be nice if this benchmark running thing had just a CLI interpreter as well, right? We don't need that. Benchotron. Where is your CLI output? Run suite. Maybe there's another thing than run suite. UI console. Only fetch one seed from global random. Blah. Range benchmark console. MK benchmark. Run a benchmark and print the results to standard output. So show options takes an array. Okay, so does this mean that instead of doing run suite, we do run benchmark console of bench Chronofold? Is that what it means? That gives a bench m benchmark result, and we need to run the bench m whatever, and we'll get an effect out of that, which we'll want to probably print. Or is that just going to print? Please import this thing. And that's the result. I see. Run a benchmark and print the result to a file. Run the benchmark and print the result to standard output. Okay, so maybe that's what we need to do. We're not benchmark to console, but benchmark to std out, which is effect unit. Yeah, indeed, that should be better. Yeah, and no, that's not what we're running. We're now running npm run bench again. And things happen. Including some wild printing of things. How come? Did we leave? Why? Oh, holy moly. That's your console output? Oh boy. Stringify results. But, okay. Is that what benchmark to std does? Because if so, yeah, it is what benchmark to std does. Oh boy. Not pretty. Okay, let's see if somebody has tried to do something in the Haskell tradition. Looks like not. Benchotron, Purescript criterion, improve benchmarking library. It came out in 2015. So we have things, and maybe we just pick among them and put what we need. Result series is an array of data points. A data point has size and stats. And stats have tons of things, and maybe that's where we monkey patch benchmark. We just remove the array of numbers here. We just reinterpret this. Okay, let's do it. Should be simpler to start from this guy, which is exactly where we were aiming for earlier. And except we say run bench chronofold, and now we don't stringify the results. I mean, we could stringify the results, but we're going to do some stuff to them first. And benchmark result is just a good old record. Size interpretation. What's in there? Number of elements in the array. We don't care about that. Slug. We don't care about that. Series is where things occur. And what we want to do is basically, what does even stringify do? Unsave JSON stringify. Okay, so I suppose we can leave that here. Oh no, except that we want to be more polymorphic because we're going to do a lot of things. Oh no, yeah, that's totally true one. Absolutely true. Welcome. Nice to see you. How's 2021? I'm gonna drink a bit. Hey. All right. Right. I see. So these are uninteresting. It's really series that I want, I think. Right, result series, and I probably have only one of those in here. I mean, title, sure, why not? We can get title. And glad to hear it's good. And then we're going to do some stuff to series. And I suppose we could do this. Well, in truth, we could do this with lenses. But I'm going to do this like a savage instead. And so series and array of names and results. So what? So we can map over that. And we can, I think, use the record syntax for this. I think that will do the record punning. We get the name out, the result out, but we want to do something to the result. Damn, that is exactly a lens use case. Oh boy. I don't want to start importing lenses in this benchmark. Okay, you know what? I am going to take a little break, just 2 or 3 minutes, and I'll be right back. And I'm back. Aha! Oh yeah, no music, right? Okay, well, Charactical already mentioned that, and I thought I'd solved it, but probably haven't. And let's take a quick look. Professionals, most professional. Okay, what's going on? I'm supposed to be outputting here. So, oh, there we go. Oops. Sorry, that's loud, I think. Or at least saturating for some reason. Could be in the music. I've switched to an ambient track. But it seems to be playing at least. Okay. All right, all right. Oh, that's an incursive way of saying things, isn't it? If you know the streamer. Okay. We wanted to. Well, I think I'm not going to avoid the lenses. I think it's just written in the stars. Caroptical is in the chat, so there we go. It just means, June, just do some lenses, dude. What's going on? Plus, it happens that in Purescript we have profunctor lenses because we're all fancy and stuff. So let's be all fancy and stuff. Yeah, right. And here we have lenses. You can be jealous if you do Haskell and that you know, it's already installed. I guess it's not compiled yet, but it's compiled now. So there we go. It's nice when you have a fast feedback loop like that. Okay, so fine, we have lenses. So what does that mean? That means that we can do. So okay, let's call this our results. And then we create a crazy lens, which will be something like, we'll call it peering, and we want to peer inside the results. But what do we want to do? We want to modify, right? So we want to kind of over, I think. So we say over. Oh, but over, what is the type of over? Over, text, etc., a function for transformation, and our thing. Right, so, okay, but maybe that's not what I want, but let's try. So let's pass it. If I pass it in identity, then that's a start, right? And we can say that our lens is going to be what? Something that goes into the records. So let's take a look at what the API for records is like in Purescript. And we have prop. So we can pass prop, oh, holy moly, with a type level label. Type level programming hello. And but really, I think we don't need that. I think we can probably compose the record syntax with the array syntax, or the traversal syntax. Or usually, you know, usually API is almost one-to-one, pretty much. But except that, yeah, they did implement the internals of this is actually profunctor lenses. Oh, you mean the prop thing, the proxy for type level? That's because of the you know, the extensible records in Purescript, which can be queried with proxy type class. So you can deconstruct the record type level, and so you get basically a type level list of labels, and that can be used to peer into a record. I think not. If I'm not mistaken, that's something that Bartosz Milewski was aiming towards, but I think there's a difficulty in implementing it with as per functors, but I think it doesn't change the API much. It's more maybe it adds some composability at some level. Yeah, I mean, to be honest, I'm talking a bit like over my pay grade, but I like to do that. Okay. Since I'm struggling even doing the simplest traversal is what I was looking at, I think. So yeah, we do want to traverse because our series, let's take an example of what we want to dig into. And you know what, let's also let's install GQ and run this thing through GQ, because I want to have a pretty view of what we're generating here. So npm run bench, and do I have GQ by any chance? No. Can I just install it like this? Of course not. That would be too easy. So actually, I wouldn't necessarily mind dropping into the WSL at this point. That's going to make installing GQ easier. How do you install GQ on Ubuntu? Give me the package. Oh, just GQ, okay. So apt-get install GQ. I didn't realize I needed to do this. Really? Oh boy. What did I do? Oh, okay. And let's switch back to the jailbase station. No vocals, no. Okay, and npm run bench pipegq dot. Right, okay. I think I need to do something ugly here because my std out is crowded. Okay, I think I'm being a little bit absurd here. I'm just going to just read the docs instead of having it in front of my eyes. So benchmark results. We get into it with series. So if I go into series, I need to compose first series and then reverse. Traversed. Would that work? Okay, no do. No, it wouldn't work. So I would actually need to prop sproxy series. And then it starts becoming so ugly that I don't even know why I'm doing that. I mean, these type level symbols are just so clumsy to deal with. But okay, we can try. And std.write, that is a benchotron thing. Yeah, I mean, you know, this is, I can explain a lot of things. Proxies in this type of language, that's pretty advanced. Too advanced, really. I would have to explain to you why types in a strongly functional programming language like we're using here, why is it so important first? And then once you get that, then I could start explaining then why we use proxies. Happy to do that, by the way. I definitely don't want to deny you the... Well, there's just a bit of a stretch to explain it. Oh, yeah. No, that's not too bad. So I have a type that's a record. Oh, this is a row type. That's not a record, and that's a bit weird. But, right, so it's not happy with the record not being a row type. While trying to match series array of blah, which is coming from our row type, with what? With type record tier 1. Oh, yeah, that's because in fact the length is over row types. Which makes things totally worse. So does this mean that in Purescript we can't compose record accessors with lenses? Yeah, we just used the dot syntax. But how do we compose it with a lens? Because if we don't have compositionality, there's another way to create lenses for field. Oh, I suppose we could, hold on. Get a person rec. No, but nothing is, those aren't lenses. Get location, no, still not a lens. Here's where the lenses come in, blah. Okay, oh, so you're building the lens from its accessor and from its getter and its setter. So that's the bottom-up kind of way. And maybe that's fine. If you want to use the lens defined using prop, it's the same. So yeah, location prop. Hey, what's all with all the, I don't remember this radio having so much vocal stuff. Oh well. Okay, let's do simpler things first. Can't believe I'm doing this. Say this will be our lens, and then we'll say just show over L identity R, and we'll say that this is, well, we start with just how about a tuple, and then we take data lens first, underscore 1. Yep. And we don't do tuples like this in this world. And we import things. And we need to traverse, right? Yeah. Underscore 1, I imported the wrong one. Data lens product. And you compile. And you give me the tuple 1, 2, because you didn't do any modification on the thing. So if I say +1, I need to section that, don't I? Or I think I can use the anonymous function notation here. I can. So that's 2, 2, right? Yeah, so I know how to do the basics thing, so at least I'm not crazy. But now, what if I do this in a record? That's what I'm a bit quizzed by here. Yeah, then it says, well, we need a tuple. Exactly. So what if we say, well, I'll just prop as proxy and all those things, you know? Then you're gonna compile. And increment 2. So is it just that hey, it works, right? But and we could have made the length manually like it's done in the blog post by doing the getter and the setter, but really that's not where we use length, right? We want to reuse the stock stuff. So that works, but then it means that I was doing something unsightly with my result, or just maybe I didn't. Well, let's just get back to this. Okay. So you have an unexpected token because we want to do notation here, and results is a row now, but let's see, bench, run bench and prime. That's my culprit right here. Run bench M gives me an effect of A, and run bench and prime also give me an effect of A. But I would think that would be a benchmark result, because I do run benchmark console. And I would suppose that this is the same A, but the fact that it has a prime in it might be tipping me off to the fact that it's actually doing some. But no, if this is polymorphic, it should be it's parametric polymorphism, right? We can't modify the A. Yeah, we can't modify the A. So, why? Is this because there's some... Okay, let's check that our types are not lying to us. Okay, fine. Just do whatever. Let's do results. And okay, tell me. Yeah, you're correct. Let's look at benchmark results again. Am I missing something? It's a type synonym, has series in it. There's no reason why I shouldn't be able to get series out of it. This type. Infer type. So, with Purescript, you got to be careful with what's up with the... Because a record and a row could be mistaken. And so A is a record, which is what I want. I actually totally want a record. But when I... oh, sorry, I'll be right back. Food delivery is coming up. Sorry, yes, I was muted. This is the actual error, and here we have some problem with matching the row. Did I? reverse, no, traverse, that's in the right order. Yeah, I'm gonna bit quiz. I'll be right back. Okay, I'm back. And I'm hungry, so let's look at this for just a tiny bit and then get our brain some fuel. Okay. It's trying to match a row type. Okay, let's try and do something a little bit stupid, like give it a record with a series in it, and call that blah. Same error. Over lengths some. Oh boy, I think this is so annoying. I know what's happening. I imported identity from the wrong package. I'm importing it from category instead of prelude, so it's not just the identity function, it's like a category call interpretation of, it's like identity lifted to categories. Oh, I hate it when this happens. Okay, where are you, identity? What? You're not even... Am I importing data.category wholesale? I can't believe it. Is that true? Or am I just tripping here? I'm using identity here, it's working fine. I think I'm tripping. Oh boy, okay, I got it. Array of record. Oh boy. Yeah, this type checks. Really time for food, I think. And therefore, what we really want is traversed here, which allows us to do the beautiful length composition thing. Indeed it does, and it shall give us blah. Oh, except it's just doing some crazy things before giving us blah. I mean, it compiles, so we know it works. It's just I reversed the traverse thing. Yeah, okay. All right, victory. And I mean, victory. I'm easy on myself, huh? Okay, let's put results here and see if at least we can get this to compile. Wow, what am I doing? Results. Yeah, still compiles, and that means that we have actually selected what we wanted to select. And that's nowhere close to where I really wanted to get, as just drilling inside this benchmark result record structure. And I guess I peeled one layer. I need to go deeper, but I'm getting there. I guess I would. So next layer, in the inception is a result series, so I suppose we could just compose this with a prop. I know I should get some food, but yeah, that's a good question. I think you're right. I just want to select. So I guess over identity is isomorphic to just view, right? I mean, over L identity is isomorphic to view L. All right, so then we get into results here. Still compiles. And let's get things a bit indented here. And then we go deeper. With the triple greater than notation, it's not as you know, zingy to read as the dot that looks like the dot accessor in object-oriented programming, but oh well. And then we traversed again. And that will get us, yeah, and then I want to select a few fields there. So yeah, you're totally right. This is really view. I think I don't care about things. And then oh, that doesn't work. Oh yeah, because traversed. Oh, so I'll stay with over for now, because I think I actually was wrong in what I was telling you. It's not exactly the same. Over result series, data point. Right, so we continue to drill down. Stats is the next level. And stats, is stats here? No, stats. Stats has what we really wanted, and so here, what do we do actually here? Here yeah, this is a traversal up to now, I think, technically, and now we probably want a lens. We want to get a smaller data structure out of this. So is it just how the nesting here? We're getting inside stats. And then how do we select a few fields from the record? The traversal's fine. Or is it about, no, I don't think. Product. Yeah, I mean, so it's basically, all right, the equivalent for like a tuple would be, well, if we have like like a tuple with 3 things in it, and we want to lens into the first 2, and so we're like, how do we compose the 1 and the 2? What goes in there? It's like a kind of product-like thing, right? Right. Yeah. So that would be equivalent to sort of projecting the record onto onto another data structure and use that other data structure to pick a few elements. Right, exactly. And so is that really the essence of indices then? So is it an indexed thing? Positions converts a traversal to an index traversal. Calling this a traversal doesn't work well in my understanding of the lenses, because really, you know, if we have a bigger, if we have a big S and that we pick A out of it, then we can totally make this A be 2 fields, like a tuple of 1, 2, and then say that the rest is 3, but that, you know, we leave it out and that we work with the 1, 2 in there. It feels like it is a producty thing. Yeah, I think you're right with that. And so maybe it is about products, but we only have 2 things in there. I traversed, huh? The with index would have, that's an interesting thought. Okay, I want to test that in the small for now. So we have 1, 2, and now we're adding 3. And we're or 4. And then what we're saying is what? I traversed here. Well, an index traversal, and then right. I traverse takes the I, but we need to use the field as an index, but because first one come I traversed. Is that so? No, our first traversed is an array, but let's remove it. We don't need it. But you know, that won't work. I mean, the problem is that the fact that we're doing type level trickery there to select things is not gonna turn on the indices indexed. Prof is a self-indexing optic, it would just work. Yeah, I think if does this mean there's something like an index instance over the fields, basically, in the way that maybe an index instance over like a tuple of 3 would then be you'd assign 1, 2, 3 to _1, _2, _3, something like that, right? And in theory, you should be able to do that because of this whole row polymorphism thing, in fact. Okay, let's Google this. Purescript lens record select fields. Well, I don't know if that's gonna work. Variants, coercible new types. Not gonna help. Let's try and get a basic indexed optic worked out. You pique my curiosity with this. Let's see if we can just do something with we need to see indexed, I think, is the type class we're looking for, isn't it? Perfunctory used for indexed optics. And there's only there's a constructor that takes a tuple, and there are instances for strong choice and wonder. No, those aren't. There's a strong instance for indexed, so that's not what we want. So that's not the type class we're looking for. Is it index traversal then? That's just a new type or a type synonym. Yeah, thanks. That's a fun, interesting thing. Yeah, index uptick, I'm going in circles. Or traversable with index, that seems to be maybe the type class. Yeah, it totally is. So there isn't a traversable with index type class or instance for records that I can see. But at least there's a pattern there that is the one that you were totally talking about. And let's try this without with like a simpler example, like something that we have. There isn't even an instance for tuple. That's quite strange. Unless it's kind of a subclassing thing. Oh, all of these are, look at this, these instances, all of these have unit as the index type. So it's only array in this implementation, at least, you know, in this library. It's only array that can be indexed with an integer. Huh. So we need to write an instance, basically, for records somehow. But there isn't one. Traversable with index, records, Purescript. In fact, that's interesting to see whether in a Haskell it's oh wow, that's a TypeScript coming up. That's impressive. There isn't a traversable with index in Haskell. There is. Okay, yeah, let's try it. But right. Or let's try it with arrays, and then let's try it with tuples, indeed, to see whether there's something going on. But it feels wrong, right? But let's try. Okay, so array of... plus it doesn't, it only selects one, so I think it doesn't necessarily solve our problem. But is that how it works? Okay, you need to add value, I traversed. And int. Yeah, so maybe there is something else going on there. I traversed. Or maybe we're not using the right one. Traversable with index IT. And so index traversal. We need to build. Oh no, this is an index traversal builder. And so. Oh, it doesn't take an input. So then we use it how? Okay, well, there's an example here. Traverse of... okay, I see what you're saying. But so that's not really what we want in that case, I don't think. I guess it means that we could use a traversal for things that might not be arrays, possibly. But then I guess we would want to select a few indices, right? So, and that would be done through what? Through some manipulation on traversals, no? I over, that's an interesting question. I wonder if there's an I over. So let's like. Okay, let's look at the example. I think that will guide us. Traversable with an additional index. Traversable with index instance must be compatible with this traversable instance. Okay, so no, we are. If it's const f, then we are passing the I. And it's just that we can use the index in our traversal. So I think, yeah, this is I traverse. Well, I would really think that it's there is a number there. Oh no, but not I traversed. Traverse with index. I'm mixing my things, but okay, so you're saying it's not, and then, well, oh, so here we receive the index, so we can say const I plus our anonymous function, but that doesn't type check. Yeah, I guess the example is use map with index, but this is in foldable traversable, by the way. This is not even in lenses. So here, how do we use an index traversal? Is maybe the real question. Index traversal. An index optic. So I guess how we use an index optic. All right, example. Aha. This guy. Right, and that's the index, and that's the value, right? No, it is. So you're right. We need to find I over, and it could be. I mean, it seems like that would be with the traversals. I traverse off. Oh, really? Completely? Oh yeah, because it takes an S. Well, hold on, no, doesn't it? Don't you need to pass it a function from I to A to FB? I traverse off takes a length, and then a function from I to A to FB. No, we need to pass that I to A to FB. And maybe we can be a little bit explicit. IA, and let's say A. But so this is expecting an index optic star F. The class hierarchy in the profunctor package is very detailed in Purescript. So hold on. Index optic. We take an index optic, and I traversed is an index traversal, and an index traversal, I believe, is a index optic. Yes, index traversal is an index optic with wander. So we are okay, more or less, with the hierarchy, but but hold on, function. Yeah, no, I'm wrong there. Cannot match end. I traversed. Is there such a thing? Traversed. There is. Oh boy. Okay. Okay, well, it takes a wonder, which seems like that's our type, but hold on. But that's, oh wow, I'm confused by this rank n type right there. It returned an indexed traversal. So we need to pass that to an over or something. Okay. Okay. Indeed. Yeah, neither do I. Oh. Is there a monad in there? I mean, let's try. Yeah, it doesn't know. Oh, hold on, what? Oh, there's some magic going on there. We've shifted something outside the array for some reason. Yes, well, sort of compiles. No, it didn't compile. It didn't compile. We seem to have some kind of T of our array that comes out because of this pure there. So I'm not sure this is what we want. But it seems like it wants these guys to be in an array of sorts. I think it wants a container here. I'm not sure why. And we shouldn't, but yeah, that does compile. So there's something going on there where we, I suspect maybe because of iTraverse maybe we're traversing twice. So could it be that we just need to over this and be happy? No. Or how about we traverse it? Just traverse it. Yeah, no, you're iTraverse off is what we want. So this compiles, and apparently it's yeah, an array of array. So we get past I. So what happens if we return I? Can we even do that? No. Okay, actually, let me spy on I. I'll const a and spy on I. That's not what I want. Bench. This is what I want. So we do iterate over 0, 1, 2. And we've concatenated our array. Oh, hold on, I'm blanking out. OBE? What? Uh-huh. Yeah, yeah. No, but I think this is us, just missing the point. But let's try what you just suggested. But I think it's fairly similar in practice. We're just not exactly there. Yeah, well done. This does seem to work. Yep. Interesting. What do these do? Yeah, we seem to be stuck in... Hey. Oh, that's the list monad playing with us. Let's take a look at your example again. Let's look at the... Well, can we even do that? Maybe with Hugo. Yeah. So that's actually the setter version. So let's take a look at whether we can find some setter. Oh, we don't have this exact one, but do we have? No, we don't have. How about at? No, we don't have. What is? There is I over. And this compiles, and let's not do our crazy thing. But hold on. Yeah, it takes an I and an A and returns a B. And is it going to tell us the same thing about returning just an A? No, it's happy. And there we go. Yeah, that's identity. Okay, and so popping back the stack then, if we could make it so that we put a record in here and then we iterate over it, then is there going to be some automatic type magic? No. It doesn't have a traversable with index instance on record. So we are back to where I was suspecting we would end up, which is that we need a record instance for traversable with index. And we have one for array, but yeah. So we need to basically project the record somewhere, maybe into a tuple of field or whatever, right? What does positions do? Okay, I am getting completely overboard with the so this was in where? So this is just in foldable traversable, and so here if we go back to data length traversal, no, data length indexed. Here we have positions, and positions is an index traversal like I traverse, so indeed we should be able to do positions. Well, I guess in this case it's just going to give us yeah, so we can do this 1 2 3. That's actually Oh. I think, hold on, position is supposed to be monomorphic to int as the index in the index traversal. So fine, but it doesn't have the traversable with index. Ah, okay. Right, so we can't use I over, we can just, we need to use over, I think. No? No. Oh, it takes a traversal. Right, right, you're right. So what traversed? Oh, and do we need to be back to I over? Yeah, that compiles. What does this give us? Same thing. Do you think that's an isomorphism there? Position traversed with I traversed? I traversed, right? I traversed, probably, right? Oh, with the record, you're full of hope. I like that. Meh. Yeah. Yeah, exactly. Yeah, you're probably right. Let's go check it out. Oh, newness. It's actually I wonder. The position is defined in terms of I wonder. Okay, my head's spinning a bit. A traversal from product. Yeah, so that's interesting, right? Because there is an isomorphism between a record, I suppose, and a product of tuple or something like that. But look, this product instance has only two things in it. I think there's probably more to do with type level naturals for indexing, in the way that prop does for records. But I think we're missing stuff. Okay, let's try. So you're saying, what are you saying? Replace traverse with each. Okay, let me do that. And each is from foldable. Okay. And so it takes a right. Right. I see what you're doing there. So if we did have a foldable instance for, so now we're thinking about doing it with a foldable instance instead of a traversable instance. Are we talking about the right each here? You're thinking each from data foldable? Is there an each in data foldable? There isn't. Oh, it should be a lens. Okay. Let's see. Oh, there's at. At is maybe at is nice. How is? Add or delete things from containers. Nah, that's not it, right? Okay, each pipes streaming. Nah, there isn't such an each. So what is it in Google? Each in data lens. Control S combinator. Each is just a traversal. Oh, but it means that something is implemented to each subclass. Interesting. extract each element of a potentially monomorphic container. Yeah, that sounds like that would be a cool thing. Right. Yeah, that sounds exactly like the type of stuff we would want. And so, but you see that that's a bit like we're back to needing an instance, right? And Haskell comes with all the instances, and often in the Purescript ecosystem, it doesn't. Although you would suspect that for something as fundamental as record, it would, but yeah. It could be. So we do have an at and an ixt also. Oh, for something that has an index, which is very record-like. That sounds like that's an improvement over what we would want. If we'd want to, you know, pattern match on the other record name, other record field name, then ixt should be giving us some of that. Whereas each is only going to give us a position. So let's see if there's anything a little bit like that in Purescript. It's a really good question. And so these are in lengths, and this might be, I mean, it sounds like that's just products, right? No, I think maybe this is missing. And this is also a kind of a variation on strength, I think. An index length, index length, a length. Sharp? I've never seen that before. The shop profunctor characterizes a length. What? Yeah, they're all right. They're right. They're changing the project, the package management system. Like tooling is evolving, so this is sometimes you know, like haddocks, they're not properly published, and so it's a bit in flux right now. What market, exchange, focusing, bazaar? Yeah, there's all kinds of interesting things in there. Oh, so I guess shop is because of bazaar, market. Holy moly! And those are all internal profunctors. I bet, yeah, I bet that if this characterizes a prism and shop characterizes a lens. I mean, that looks a lot like the basic getter setter thing. So I don't know. How about just index? The focus element might not be present. So that does for maps. Okay, that quite looks like each and at. And ix, you know, yeah, it's quite like at, I think, if I read this properly. Each is not indexed, but at is. Yeah, you're right. Right, look, at and oh no, yeah, the method is at. So I think they're using different names here, but I think this is it, I think. Set ix1 888, yeah, that looks like it, right? You can view at a specific index, and so you're right. If we had a ix instance for a record, except that you know, for maps we do, but for a record, because it has type safety, then you need type level machinery to do that, and I'm sure it's doable. But it's a little bit over over my pay grade again. What's this object? Is that a JavaScript? That's a JavaScript object. Hold on, what's the order in parameters here? IX takes an A to traversal prime of MB. Yeah, so that was my intuition, right? That we do something like IX of 1 or something, then we'll over L identity or something. Or like let's, well, yeah, over L identity, and then do like 1, 2, 3, and then that will give us 2. Yeah, compiles, and it doesn't give us 2, gives us 1, 2, 3, because I hovered over it. And so if I view and remove identity, is that right? No. Or we need to preview because it's prism thingy. That's because the optic is a data lens traversal tailored to the case where there's a single element of interest. Right. So it is a prism. Interesting. Huh. We shift to prisms when we move there. So interesting. Yeah, we get the just 2. And so yeah, I think you're right. It should be doable. And yeah, in the absolute, I should be able to do this. I agree. I think I actually know enough to do that, but quite a bit of work, because the type level machinery I'm not yet super familiar with. I need to reread, Thinking with Types, Sandy's books, and I mean I get it, right? But it's just not pretty. I do wish for dependent type sometimes. Okay. Hey, Barry, this was really awesome to do a little bit of, digging into things together. That's actually reminded me of the type of stuff that we were doing with Chris when he was in Berlin. We'd meet pretty much every Sunday at the coffee shop and dig into things. And, that was really cool. Yeah, really appreciate your time. And, I will see you around. I'll spin up my thanks for watching amazing thingy. And actually, and it makes me realize that it should have the chat box. So I'm going to correct that and be gaining some professionalism points by doing paste here. And well, yeah, it works. All right, take care.